Alrighty guys, I want to show you how to connect a simple DC motor to your Arduino and actually control the speed that the motor spins at. A DC motor is pretty easy to use if you just want it to turn on and off. For example, let me plug this motor in here on my breadboard. I can just connect one of these leads of the motor to a high voltage source, such as the 5-volt source on your Arduino, and I can connect the other lead to the ground pin on the Arduino, and that'll apply a DC voltage, a DC current through the motor that will turn the motor on. There we go. Turn the motor on and make it spin. Easy enough to hook up. Now, if I want to actually control the speed that this motor can spin at, I got to do a little more complicated things. That's where this guy called a transistor is going to come in. The transistor, it's got a flat edge, and I've got the flat edge pointing up here. It's got 3 leads. They're called the collector, the base, and the emitter. And so you can think of this as a kind of a water valve for electricity. Think of a valve, as I turn the valve, more water can flow through the hose. As I apply more current, more electricity to this base pin, that allows more electricity to flow from the collector to the emitter. And so it's a very simple control mechanism for devices like this DC motor. So let's look at how we're going to hook this up. I'm going to take my transistor, plug that into my breadboard somewhere here, just kind of out of the way so I have enough room to work. It doesn't matter where you plug that in, just make sure the 3 leads of the transistor are on separate rows. Again, I'm going to use that middle pin, that base, as the control mechanism for the transistor. And so to do that, I'm going to plug in a resistor. And so that's plugged in the same row as the middle pin of the transistor. And I'm going to take another wire and run that over here to one of my digital input-output pins. I'm going to pick pin 9. And so that's how I'm going to apply a signal to that base in order to let more electricity flow from the collector to the emitter. So the emitter, that's the low voltage side of this thing. That needs to be connected directly around to the ground for this particular type of transistor. So I'll connect that to the ground pin, and then the motor is going to be hooked up to the collector. And so let me go ahead and do that. I'm going to hook one end of my motor, one lead of my motor, to the same row as the transistor, and stick the other end of my motor up here somewhere. It doesn't matter where. And then, of course, I need to connect this to a high voltage power supply. And so I'm going to connect that same row that this other lead of my motor is connected to. I'll plug that into the 5-volt supply over here. Alright, so that guy's running because I've already got some code loaded up in here. Now this diode is going to be used as something called a flyback diode. That's going to prevent surge current from flowing backwards through my circuit and potentially damaging things. A diode, just like the LED, which only works in one direction, a diode only lets current flow in one direction. It lets current flow from the white mark towards the other side of the diode, and that's going to just get plugged in there, and that'll protect my circuit just a little bit. Now, we want to actually figure out how to write code for this. Well, the code for this is pretty easy, even if the circuit's a little bit complicated. So right now, I don't have any code written here, so let me send that up to my Arduino. To get started with this code, it's going to be pretty straightforward. I'm going to create a variable that's going to tell me what pin I'm using to control my motor, and I chose digital pin 9. So I'm going to say, let's say motor underscore pin is equal to 9. And so that's going to just create a variable that's storing what my motor pin's connected to. Of course, a motor is an output. And so inside the setup function, I need to set the pin mode of the motor pin. I want to set that to be an output. Easy enough. And now I'm ready to control this guy inside the loop function. And so, for example, if I want to pulse the motor like I was just doing, turn it on and off, I could use the digital write. I could do something like this. Digital write motor pin. If I want to turn it on, I can supply a high voltage, and this would be just like connecting it to that 5-volt line directly without using my transistor. So let's see what this looks like, and then I'll show you how to actually control the speed of the motor. Let's say I want to turn it on for 2 seconds. That would be the equivalent of 2,000 milliseconds. So I would turn my motor on for 2 seconds. And let me do another digital write to turn my motor back off. So let me send a low voltage signal to turn that motor off. And let's say I want to turn it off for half a second. So half a second would be the equivalent of 500 milliseconds. And so this code should just turn my motor on and off, which it looks like that's working pretty well. Now, if I want to actually control the speed of the motor, that's not going to be a digital signal. A digital signal is just on or off. It's just high or low voltage. In order to control the speed of the motor, I have to use what's called an analog signal. So the function to use is analog write. And so I'm going to replace digital with analog. And here, instead of high and low, I can actually set a range of values. An analog pin on the Arduino using as an output will take a value between 0 and 255. That's corresponding to 8 bits. And so, for example, maybe I want my high speed to be, I don't know, correspond to a value of 150. And maybe for the low speed, I don't want to turn my motor off, but I want it to spin kind of slow. So I'm going to set that to 25. Let's see what this piece of code does. So click upload. And so again, that's spinning my motor a lot slower. Actually, it's kind of hard to tell when it's spinning really slow. So let me make this spin slow for 5 seconds. I think I'll make it a little more noticeable. I can feel it moving, so speed of 25 is not quite enough to kick the motor on. So let me see what the speed of 50 does. But you can experiment with these values, and you should be able to get different speeds out of your motor. So there we go. Now it's spinning fast, and then spinning slow for 5 seconds. And it picks up, it spins fast for 2 seconds, and then spins slow for 5 seconds. So you can control the speed of the motor very precisely using this analog write function and one of the digital input-output pins on your Arduino. Now, to actually use the analog write, I just said digital input-output pins. To use the analog write, you have to make sure you're plugged into a pin that's got that little tilde squiggle next to it. That's a digital output pin that can do something called pulse width modulation to simulate an analog signal. So not every digital input-output pin will actually work with the analog write. Fortunately, pin 9 is one of those pins. So, congratulations. You can now turn electricity into motion.